But at the powers that we're looking at, that most of these meters transmit and most of the communications devices around, it really is a very minimal power. Like I said, your laptop is cooking you 10 times more than anything that's AMI or power industry related. Some of the initial truths about cybersecurity. One, I'm one of those people, I'm the outside the box guy. You know, I'm come out from way out in left field. Some people say I have an evil bit set. True, but also with that comes a paranoid bit. So, you know, the more I know, the more leery I become of different things. One of the things that from this is most of the people that are building these systems, one, don't have the evil bit set. So they're not really thinking of things bad that are going to happen. Attack vectors, you know, I walk up to the device and go, ooh, here, let me see what happens when I hit this button. The engineers and developers that are building these things, they're trying to get it to work, which is by far easier to make it work than it is to break it. I tell people I have the easiest job in the world. All I have to do is find the one mistake that you've made, where you've had to make thousands and thousands of correct decisions to even get it to work. You know, and that comes down to, generally people don't think of the easy way to break things. And, you know, we've heard test it yourself, you'll go after the low-hanging fruit. I guarantee if you miss it, I won't. You know, low-hanging fruit is something I kind of, my trademark. I don't have to be super intelligent to break into your systems. All I have to do is find the weakest link in there. You know, most of the things, especially automation, especially distribution automation, is, you know, these things used to live within a fence, within a data center, but as these things are being put into the field and the networks are being pushed further and further into the field, now we have data concentrators, aggregation points that live in people's backyards, you know, on a box, on a power box that's on the ground, you know, in back alleys, places that are secluded that, you know, every 5 years somebody might drive by that location to see if it's still there. And that really is increasing the attack surface. You know, I don't have to break into a substation. I do not have to come into your data center to attack you anymore. You're bringing those points to me now. Oh, PS3 attack. You know, that I threw that in there because, you know, the game companies have been spending a lot of money. You know, physical security to them has been a priority since day one because, you know, kids will be kids, and if they can steal a game, they will. And the reason for the PS3 is what it comes down to is intent. If you piss somebody off and you become their target, it becomes very difficult to defend yourself, because there's always going to be some place, some mistake that you've made somewhere. And as in the case of the PS3, it came down to a single key, which was a key to the kingdom. Well, now, you know, Sony's going to sue this person, and they've already confiscated it. Well, as soon as that was published, I know 30 seconds later I had the hack. I'm sure there's 10,000 other people that also have that hack also. So once it's out of the box, you're never going to recork that thing. Security versus operations, and this is something that we run into over and over again in penetration testing and talking with the different silos within a utility. And unfortunately, within a lot of utilities, these silos do not communicate very well. So, you know, how do we get the different players involved to work together? And, you know, this is actually from an engagement. We were specifically asked, where should we mount our devices in the field? And, you know, from my point of view, from a security point of view, is put it at the top of the pole, make it as inaccessible as possible. Well, operations goes, oh, no, safety, that's not going to work. We have to have better access to this device. And my question or my response to them is, well, you're thinking about how you do business today and not how you're going to do business in the future once these devices are installed. The safety issue, and this is a hypothetical recloser here, is, there's a live wire on the ground and the support personnel need instant access to that box to be able to shut that power off. And I'm going, hang on a second, why is it still on? This is a network communicating device. As soon as a phone call comes in, that line should be dead. So the technician that shows up on site is to repair the damage and put the service back in, reinstate the service. So you have to think not only how we do it today, but how it's going to happen in the future. Well, operations says we want instant access to this and we want to put it at chest height. Unfortunately, that seems to be the normal. As I drive around the country, unfortunately, I pay attention to the overhead lines and the boxes hanging on the poles. This is where most of them are installed. Almost everyone that I've seen in the field, that's where it is. Let's go to a compromise. We're all adults. Let's split the difference. And that really isn't a compromise, because the reason for putting it halfway up the pole and not the top is very minor, but actually placing it halfway up the pole is an operational issue. It's not really security. Reason? If you have a wireless communicating device and say a UPS truck, FedEx, there's not a road in the country anymore that box trucks or some sort of commercial vehicle go by. It's aluminum. Guess what? When it drives by, that recloser drops off the network. When it drives off, it comes back up. Now you have a network that is constantly, all day long, going up and down, and guess what? After about 15 minutes of that, they're going to ignore it. It's nothing more than a false positive. If you have any kind of intrusion detection, which is one of my things on the physical security, is at least know if I open the box. Most people, most of the devices we see in the field, they have no indication. I can do anything that I want to these devices because there's no indicator that somebody's even opened the door. So, one, you need notification, and second, somebody has to be paying attention, and you need policies and procedures in place to either dispatch the proper legal authority or dispatch one of your trucks. Mike was looking at the slides, and my slides are kind of cryptic. They're really more for me, so I remember what I want to tell you. But Mike says, okay, I see this point, which is completely different than the point I'm trying to make is, well, you put it halfway up the pole, now all they have to do is hop on the back of that truck, and now they're at your box. So there's no 100% answer, and it really comes down to levels of difficulty. We talk of security in layers, and this is just one cost-effective, it's not going to cost a whole lot of money, but there is a financial, component to that, because now when I have to repair it, I have to roll a truck that has a lift bucket in it. So, it's not free, but it's a lot less expensive than some things you could do. Let's do the easy things first. Let's get that right. One of the things that I do also is the embedded. I've got customers that have enough trust in me that they send me a bunch of their devices to do with what I wish, which is I appreciate. I learn a lot. But when I get a device, I first thing I do is rip it open and start looking and seeing what's in there. Give or take a few components, they're the same. You know, if they're not the same chip, it's the same class of chip. There's amplifiers, there's data, there's comm modules. You know, they're, you know, a handful of components, and everybody in this room fits in there. So, you know, from the state of the way electronics are built today, when you start looking between these different components, there's not hardly any security there whatsoever. You know, it's an IC squared interface here, it's a serial interface there. The sensors may be an analog input, it may be a digital input, it could be simply high or low, on or off. So when we start going through there, all these touch points between these devices, you know, before I dump the memory of the processor, before I start looking at your source code or your embedded systems, you know, I do the simple stuff. I attach at these communications points between the processor and the outlying devices. That could be an amplifier for a CT coil, which is part of your metrology. You know, there's certain things with that become very easy to tweak. You know, I can go in and the amplifiers are now smart and, you know, they're updatable, and so I can change the amount of gain from that. I haven't touched the board, I haven't modified anything. You can look at it all you want, you'll never see that I was in there. But I've changed the gain of your amplifier on your CT, so now there's a 30% credit to my bill. You know, I'm not charged for the full amount of power that I'm using. The other thing, I don't care what kind of encryption, what kind of security you put in here, once I get to the sensors, it's game over. I have not seen an encrypted sensor yet. You know, an on-off switch, a relay. You know, unless you're going to put a processor in each one of these sensors, which now those sensors become an attack point in themselves, listening to those points as they talk to the processor is a very simple thing. Sometimes to shut down an entire system, all I have to do is put 3.5 volts on this pin. You know, I haven't cracked anybody's encryption. I haven't done any hardcore work other than this is a simple switch. This turns you on and off, and I turned you off. So it really, you know, when you get down to the brass tacks of this, it's going to be very hard to secure those sensors just because of the nature of the beast. What is the mitigation to that? Is access control, knowing when somebody is in that box. Because short of packing that box in concrete, which potting compound, everybody, well, you put it in acid and it comes off, and you didn't pick the right potting compound. I've run into some personally that were a nightmare. In fact, it was customer paid me lots of money and I'm still going to chip this stuff off, or get the vendor to send me one unpotted. The vendor sent us one unpotted. But, you know, from a cost perspective, from, you know, making it more difficult, potting it was tremendously effective, because rather than a 20-minute hack, I was going to spend 3 days before I saw green board. While I can do it and not make any mistakes and things like that, the honest truth is that's very difficult. You know, pen testing is nothing more than, it's like a game of hide and seek. You know, you've hidden things in there, and all I'm doing is trying to find information. And any information that I find, I'm going to use against you. It's, you know, what information is available from your vendors, you know. What information is available from the chip manufacturers that you're using? You know, how much of their security, how much of their encryption is published that I can get at? And literally, I get a device, I open it up, I write down the chips, I go out to the manufacturer site, and I start learning. And eventually, I'm going to find a hole somewhere. You know, one of my favorites is the comm modules. You know, you build all the security into your system, and you've got it locked down. You've done a good job. And unfortunately, what I do is I'm going to come in, and I'm going to yank that COM module out of that device. Just from experience, I've learned that most of these COM modules remember things. They remember a lot of things, things that you wouldn't expect them to remember, things that you don't want them to remember. So as I grab that COM module out of your device, now I have a port fully configured with authentication, with access rights to your network. Now I've pulled this COM module out, so all the security that you've built in is now null and void. Now I hook you up to my attack PC, and I use your COM module to beat you with. Because now I have my OS sitting behind it that I can run all the funny tests that I want to do and let it sit there and bake and shake for weeks until it finds a hole. So, what is the mitigation? It really comes down to access control and paying attention, because unless you're going to keep me out, once somebody has access to a device, it really is game over, and you don't have to be real good to do it. I hear from my customers very often that, we're secure, we're encrypted. Yeah. To me, encryption is nothing more than, it jumbles things. I'm not a crypto expert. I never had to be, because I can break these systems normally without knowing zip about crypto. Depending on how you implement your crypto is crucial. What you are encrypting is crucial. What you're doing with it is crucial. The easiest thing that I beat people with is, we have an encrypted stream and we're going to do a meter disconnect. So they send this disconnect command and I happen to capture it. Well, I haven't cracked your crypto. I haven't done anything like that. All I'm going to do is 2 weeks from now is I'm going to hit replay and send that back to you. Unfortunately, most times than not, it's going to work and it's going to shut that meter off. Same thing with demand response, the one-way pager systems. That's like shooting fish in the barrel. Information leaks, like I said, when I go into an engagement, I'm looking for information wherever I can find it. Paging systems, a lot of utilities use pagers to, control field assets. People go fix this, go fix that. Well, when you look at that traffic, and it's not very hard to do, there's, go up to the web, look for paging decryptors, and it'll work with any ham radio on the market just about. But not only do I get information as far as people's names, I get their telephone numbers, I get their email addresses, and if you do a little background research, you find out that this is a director of power generation, that this is a field supervisor for distribution. Just having those email and phone numbers is a fantastic social hack. I'm vendor XYZ and we're having an issue communicating to this device. What did y'all reset the password to? Oh, it's blah, blah, blah. It'll come. I mean, it's not that difficult. Even though you've sent your staff to training and trying to get them, be careful. Don't answer every question that is posed to you. Make sure that who you're talking to is who you need to be talking to. When you see pager information going back, Tom is talking to Larry. I call up Tom going, yeah, this is Larry, what's the problem? It's easy. So you got to look at where you're bleeding information. Is it from your website? Is it from your vendor's website? Is it from the vendor's supplier's website? All that information becomes tools that I use against you. What do you encrypt? If you don't add a variable to that encrypted string, especially with control sequences, embedded systems, they're very short. One of the things that makes encryption work is you have this big stream of data, and it's all different, and it's hard to make correlations on how this works. But when these data bits are really small, 20, 30 bits, because of bandwidth, they've tried to squeeze these controls and these actions to very small. So I'm not having to review large streams of data. It's a little blurb. And if I can capture that little blurb, and you haven't added a differentiator or something that changes each packet that gets sent, I just keep replaying it to you, and you turn the meters back on, and I turn them off. And we can play that game all day long.